All right, so when looking at similar figures, there's a couple things that you want to look at to identify if they are similar. And to be a similar figure, it must have the same relative shape. And in the end, you'll realize it is the same shape. The angles, the corresponding angles, must be equal. Okay, must be what's called congruent. However, the orientation, so whether you slide it, you rotate it, you reflect it, that can change, and the size can change in proportion. In other words, by a scale factor. So the first thing you want to look at are the shapes looking like they're kind of the same. Yeah, they do, but we can't really tell. Are the angles looking like the same? So the angles are equal. Okay. Yes, what you should see is if you saw this is 90 degrees, this is 90 degrees, this is 90 degrees, you would look at the degrees and spot, are they corresponding? Are they equal? Yes. All right, so what I noticed, what is the difference here? The sizing is the difference. So the piece of this that we need to fix and look at is to see if the size is in proportion. So how do we do that? What we have to do is set them up equal to each other to identify and say, okay, are they using the same scale factor? So you come here and you look at the rectangle and I say, okay, this is 10 centimeters. So I'm going to look at the vertical line of J, and the vertical line of J is 10 centimeters. And according to that same exact position in another figure, you're trying to figure out where is that position? What is it equal to? So if this is 10 and this here is 4, 4 centimeters. Right now, I'm looking at just the J. Then I go to my other figure, and again, if I looked at the vertical line first, then in your next figure down on the bottom, you need to go ahead and you want to look at the same corresponding position, which would be the 5. Then I looked at the 4 centimeters here. So in that same position, I want to look at the 2 centimeters there. Okay, then what you want to do is you want to look at the other section to see if that guy is also equal or not. So what you can do is say, is the fraction or the scale between these guys the same? Now if we were to come over here, the scale for 10 centimeters, the scale is 5. The scale here for the horizontal, and the scale for the horizontal, or what you might call the width, notice that both of these are by 2. Okay, so then that means that these are in proportion. Now let's look at if we were to do the same thing, but with the further one. Okay, if we did 10, this would be 12 on the bottom. If we did 4, this would be 5 on the bottom. Now look at the ratio. Is it still by 2 or is it changed? Notice this fraction here, 10 divided by 5 is 2 equals 2. This guy right here, 4/5, if you were to go and simplify this, 2 goes into 10 5 times, 2 goes into 12 6 times. 5/6 does not equal 4/5. That tells you that this last guy is not going to be in proportion because they are not going to be proportionately the same. In other words, the ratios. So what you do if you need color when you're looking at this right here, the vertical line of J is where I got my 10. And that vertical line of J, I have to keep, remember, you have to keep the figure across from each other the same. So figure J, I put on top. Then what I did was take the same corresponding positions. So the vertical of K, which was 5, because vertical and vertical, and then the 2. And so this is a figure K. Once you see that they are equal, then you know that those are the two that are similar. So for this rectangle, J and K are similar. A picture 10 inches tall and 14 inches wide is to be scaled to 1.5 inches tall to be on a web page. How wide should a picture be on the web page in order for these to be similar? So if this is your problem here, I highly recommend and I will require that you draw it to make sense for your given. So you have a picture. So my first one is going to be a picture. And that, instead of J, I'm going to write picture there. And this guy has to be 10 inches tall, so 10 inches, and 14 inches wide. So it's actually wider than it is tall. Okay, that's the picture. And it is to be scaled to 1.5 inches tall. Ooh, that's going to be really small. Okay. And this is for the web page. So 1.5 says for tall, so it has to be in the corresponding position, tall with tall. And then it says how wide should the picture be? So your given is in a drawing position so that you get it to where it looks like those problems. So now what are you supposed to do? If you're ever missing one piece, they are telling you that this has to be similar, which means that they have to be equivalent fractions. So you would just put a variable x on the position they don't give, which means you're going to be using cross products to solve. So I go back to how I solved my thing at the top. We're going to put the picture on the top, and we'll put the web page on the bottom. Okay, so if I put the picture on the top, I'm going to do my picture in yellow, and I'm going to put my tall, needs to go on top, so I'm going to put 10 inches on top. Okay, and if we're looking at 10 inches on top, so the first fraction is going to be for the tall, and the second fraction is going to be for the how wide. Okay, so it's 10 inches tall and it is 14 inches wide. Now I go to my web page and its height is 1.5 inches and its width is the x because that's what we're looking for. That's where I got these values, and your pictures are going to be up on top. Now, once you have this, you just do your simple cross products. All right, that means that 10x equals 1.5 times your 14. So then you can come at this point, yes, you can use a calculator if you don't know how to do the multiplication, but I should see this step. So 1.5 times 14 gets you 21 equals 10x. Well, now that I have 10x, I have to get x by itself. So since this means times 10, we divide by 10. What you do to one side, do the other, divide by 10. That means x is going to be 2.1, and what's the unit? It's inches. What does that technically mean? That means that while the picture is 10 by 14, the web page will be 1.5 inches by 2.1 inches. So this scale right here is 2.1 inches. Could they further go along with this and say, now can you figure out the area? Yeah, to figure out the area, you would do length times the width. to get the area of this, length times the width to get the area of that figure there. All right, a t-shirt has an isosceles triangle with a side length of 4.5 inches, 4.5 inches, and 6 inches. An advertisement shows an enlarged version of the triangle with two sides that are each 3 feet long. What is the length of the third side of the triangle in the advertisement? Well, the first thing I see is the word isosceles. And in my head, an isosceles triangle means that two sides are congruent. They have the same measure of length. So that tells me for this first figure here that these are going to be two sides because they're the same measurement. So for my first triangle, the t-shirt, okay, so this is the t-shirt. And then it says for the advertisement, it's going to be enlarged. That means bigger. So that's for the advertisement. Now I'm going to go and fill in what I see from my initial problem. So again, these are your givens. So in here, I see a t-shirt is going to be isosceles. So that tells me I should put ticks here because they have to be equivalent on two sides for an isosceles triangle. This is going to be 4.5 inches. This is going to be 4.5 inches. And this has to be the 6 inches. All right. Then they tell you that the advertisement now is going to be 3 feet long. So each of the sides are 3 feet long. Two of them. So these have to be the same. 3 feet, 3 feet. And then it says to find the length of the third side. So we have to figure this piece out right here. So looking at these and recognizing if you have the ratio length to length, then you must have the same measurements. So this one is inches. This one we need to convert to inches. All right, so what you must first do is do a conversion factor. That means you must figure out what 3 feet is in inches. Well, for every 1 foot, there are 12 inches. So 3 times 12 gets you 36 inches. So instead of 3 feet, we're going to use 36 inches instead. Now that I have the same units being compared, now I can go ahead and set up my proportional ratio and my equivalent fractions. So I'm going to put my t-shirt on the top and I'll put the advertisement on the bottom. Now, in order to find the measure, you only need corresponding sides for one. So I'm going to use 3 feet and 4.5 feet. I'm sorry, 36 inches instead of the 3 feet, but I'm going to look at the 3 feet side, and I'm going to correspond that with the 4.5 inches. Okay, so for the t-shirt, this is 4.5 inches. For the advertisement, you want to make sure you put the inches measurement there. So this is going to be 36 inches. So again, what does the first fraction correlate to? It's the corresponding, we'll just put height. It's not technically a triangle height is in between here, guys, but we're just going to say, okay, or if we'll say the height diagonal. That makes more sense. Okay. Then you have to get the second fraction. Well, the second fraction is looking at the piece that you need. Okay, well, for the t-shirt, t-shirt goes on top. T-shirt is going to be 6 inches. And the other one is where your X value goes. So now you have the pieces you need. I highly recommend you write this. What does this mean technically in ratio? It means t-shirt to advertisement, which can also be written as t-shirt ratio advertisement, or as a fraction. Keep in mind they can give it to you all which way, and you have to understand what they say. Now you have it to where you can do your cross products. Okay, what does that mean? That means take 6 times 36 equals 4.5x. Now you do your 6 times your 36. You get 216 equals 4.5x. Since x is times 4.5, you have to do the opposite. So divide by 4.5. What you do to one side, you do to the other, 4.5. Now when you get x by itself, so divide by 4.5, you get 48. What does that mean? Okay, that means that you're going to have 48 inches. Now, if I put 48 inches here, is that going to give me the feet? No, so I need to figure out what is that in feet. Well, because I need to have both measurements, 48 inches times inches in feet. For every 1 foot, there are 12 inches. What you end up getting is that this is going to be 4 feet. So this is technically 4 feet. So that you get it back to its original. Since they gave it to you in feet, your answer must be in feet. So it's a double-step process to solve and to get the answer.